In this video, we'll look at various memes from both the machine learning memes and r/programmer humor subreddits. This video is meant to be both humorous and educational, so I hope that you can both laugh and learn a few cool new things about this technology that's really important and that impacts all of our daily lives. Without further ado, let's take a look at the first meme. So here, my RL algo getting caught in a local optim. So what he means by LR is the learning rate. That's a really important hyperparameter, which measures like how fast you want your parameters to change as you apply the gradient of the cost of whatever area you're using. So this guy like looking around, moving around, that's what happens whenever you don't set your learning rate correctly. If it's too low, it's gonna kind of move down to the optimum, but very slowly, and it's gonna result in a really slow training time. But if your learning rate is also too high, it's gonna kind of bounce around and not really converge at the local minimum. Oh, here's a good one. Putting those 15 billion parameters to good use. So I'm guessing that's GPT-3. Am I right? Avoid overfitting by tuning the size. Avoid overfitting by using dropout, by using L2 regularization. You could also use L1 if you're into that. Deny overfitting exists. Kill overfitting by training the whole model with the whole internet so all the sets are stored in the model. So this is referring to OpenAI's GPT-3 neural network, which came out last summer. And what this meme in particular, the overfitting is like one of the most prominent problems when it comes to machine learning in general, not even with neural networks. It's kind of like you're trying to model your training data, but you're modeling it too close so that it doesn't generalize well. And these are two of various overfitting techniques. You could also try dropout, alpha dropout, and specifically maybe Monte Carlo. And you could also try normalizing your data as well, using batch normalization or something like that. Here's a good one. When you move on to deep learning, thanks guys. So long partner, k-nearest neighbors, decision tree linear regression, support vector machine, k-means, clustering, random forest, XGBoost, logistic regression, naive Bayes. I mean, you don't have to stop using those algorithms. Like, a lot of those work really good in Kaggle competitions or other various things, but this refers to like deep learning as a subset of machine learning that specifically deals mainly with neural networks and just really complex tasks. It doesn't have to be neural networks, but it mostly is, especially modern day versions. Oh, here's a good one. Me starts training a convolutional neural network model, early stopping. We will watch your validation laws with great interest. So early stopping is kind of a way to stop training your neural network model. This is specifically for neural networks. When you stop training it before like before the loss comes back up. So if you take a look at like a validation loss graph, this is going to make sense. It's going to go down, but then eventually it's going to hit a minimum and then go back up. And then once it hits the minimum, goes back up, that's when you start overfitting your model. So early stopping is a way to avoid that. Here's another good one. Artificial intelligence, y hat equals weight transpose x plus b. So this is kind of like the running joke. There's a lot of these on this subreddit where it's like you want to learn AI, but then you come across all the math and it kind of gets scary, which is definitely a true thing. In this case, this could refer to any machine learning algorithm. It could refer to like a neural network with output and then connected input. Okay, I've seen a lot of similar jokes to this one. Understanding maths behind deep learning, this is brilliant, but I like this import TensorFlow as TF. You forgot from TensorFlow import Keras. From TensorFlow.Keras import Keras, but yeah, so there's a lot of these memes on the subreddit where it's really, when you first start learning like deep learning specifically, you're gonna be looking at a lot of gradients. So you're gonna be looking at vector calculus. You're gonna be looking at a lot of probabilities and it's like a lot of regression as well. It's not really easy math, especially if you don't come from a statistics or even math in general background, but really at the end of the day, the guy on the bottom where he's like practically using everything, that's really what you want to do at the end of the day. I mean, knowing the math is obviously very important, but don't let it stop you from like using these models for what you wanted to use them for. The AI model they want, the data they give. Yeah, so this reinforces the concept that machine learning algorithms, they're only as good as the data you provide it, and you got to make sure the data is representative of the future data you're going to use. And data is super important, but yeah, the quality of your data is really important. That's why, in general, a lot of the time, a huge chunk of the time when you're working with AI and machine learning is spent pre-processing data because a lot of algorithms and neural networks, they don't really work well if your data is not standardized, if it's not normalized, or if it's not flattened, if you're working with images or various pre-processing, or if it's categorical, you gotta do one hot encoding or one of those other things. Okay, my model and training data, my model on the test data set, yeah. This is another overfitting meme, yeah, it's in the title. Uh, it's really it's not easy to prevent your model from overfitting, especially at first. It requires a lot of trial and error often when you're dealing with configuring which hyperparameters you're using, especially if you're dealing with neural networks where you have several hyperparameters you got to be aware of, and if one's wrong, then the whole thing might as well be wrong. So yeah, it's really, you got to know what you're doing to prevent overfitting. Oh, this is a good one. Transfer learning be like custom layers, pre-trained layers. Okay, this is a funny one. So transfer learning is when you're reusing the hidden layers from some other neural network. This is specifically for neural networks. When you're using the hidden layers from some other neural network that does a similar task, you can just borrow the hidden layers and start learning from there. And this is what transfer learning is. So then your custom layers, your pre-trained layer. The pre-trained layers are layers you got from your other model. Custom layers are layers you having. Usually these are input or output or any dropout or other layers you have. ML, AI, computer newbies, data structures and algorithms, mathematics. Mathematics. Yeah, machine learning AI, it's really statistical modeling. That's the best synonym I can give it. It combines a lot of linear algebra, some vector calculus, and statistics, especially probability. Also, distributions are really important, especially with like unsupervised learning. Machine learning in a nutshell. Oh no, my dog accidentally knocked down the trash and discovered old cheesy pasta in it and is now convinced trash cans provide an endless supply of cheesy pasta, knocking over every chance she gets. This is the cautionary tale about how this is some really cool, this is some really funny overfitting jokes, but it's also, this is an example of supervised learning where you show your dog is in the model. In this case, you're going to show it a trash can with food in it. It's going to think all trash cans have that same food. That's also that's a pretty big overfitting there. So I feel like as the dog reaches more trash cans, its learning rate, its validation accuracy is gonna go up and its loss will go down. But right now the dog is severely overfitting trash cans. Why do you always import that? Import numpy as np, pandas as pd, matplotlib, import pyplot as plt. Hello world, professionals have standards. You also forgot, import TensorFlow as tf and import Keras backend as k. You could also do import Seaborn as SNS. These are just various machine learning libraries. These aren't technically machine learning libraries. These are mathematical libraries. Oh my gosh. How to confuse machine learning. Oh my gosh. Okay. This is by far one of the funniest ones. I don't know why I find this so funny, but confusing. That would be really great to train it though on. So I guess your goal with this model is probably to train the dog, but you're comparing it with a bunch of muffins, which look like the dog, but you want to distinguish between them. We have 3 dogs here. Yeah, I count 8 squares with dogs, and this is 16. So half of them are dogs, half of them are there. I guess you could confuse a convolutional network this way, but it's actually, I would say it's pretty smart to include these muffins in your training data. Okay, let's look at this one last one. Model trained for 1,000 epochs, for 100 epochs, for 1 epoch. I mean, this happens. So this is an example of underfitting. And what it does is it's not fitting to the training data enough. But underfitting tasted so good. Yeah, but I mean, I think this would be more funny if this was overfitting, because overfitting is a problem that you would encounter probably 100 times more than underfitting. Don't quote me on that. Yeah, great meme, except it's backwards. Yeah, I kind of agree. Okay. Me setting large learning rates, my model trying to minimize the cost function. Yeah, so learning rates, as this was, I talked about learning rates in an earlier meme, but yeah, learning rates are really important. In this case, setting a large learning rate means your model, if you look at like an optimization curve where you have error versus your like parameters, and setting a large learning rate is going to make it kind of bounce back and forth too much to the point where it might not converge to the local minimum. It might just like, I guess, diverge, or it might converge to like something above the local minimum. So that's why learning rates are super important. Machine learning developers on convolutional neural networks, CNN convolutional neural network. Okay, so they're kind of playing on the abbreviation of CNN, the news organization, and convolutional neural networks. AI enthusiasts, weights before dates, gym lovers. Weights as in weights and normal weights matrix, yeah. So weights are the parameters that you often train in machine learning, especially with neural networks or other machine learning algorithms. Weights is one of the parameters you train that you want to optimize, and I think they're just they're kind of connecting it to the weights people lift at the gym. But it's easy to understand. Linear regression versus the guy she tells you not to worry about, neural networks. Yeah, I agree with this. So linear regression, it technically is machine learning if you define machine learning as the optimization of parameters of that a statistical model does. So in this case, you're optimizing your why is it A and B? Why can't you just do M and B like a normal algebra model? But this is a linear model. It's like one of the most basic ones. I don't think like many machine learning people who work with machine learning, I don't think they very often use linear regression. I haven't. The closest thing I've come to it is logistic regression, but that's even for predictions. Neural network is a lot more complicated. I will say that the neural networks, you have a lot more hyperparameters to worry about. You have several. You only have, and the linear regression only has 2, so there is definitely a trade-off. But yeah, on that note, I hope you found these memes funny and educational, even if you know nothing about machine learning. You could look up all of these things if you're unaware of them. But yeah, thank you for watching the video. I hope you found this entertaining and educational. I'll see you in the next one.